If you run a large VEX Robotics program, there's a good chance you've got a lot of these V5 motors hanging around. Someone wrote no connect on this one. Someone wrote bad wire on that one. Is that even a motor problem? Maybe it was just the wire they were using or the brain or something. You don't really know if these motors are actually bad. And if you could test them, you could get them back into circulation without having to buy quite so many new ones. So with a small test jig that's easy to build yourself and a nice program called Kippis, you can test these motors and verify that they're still working correctly. The hardware here is pretty minimal. You need a known good motor to test with initially, green motor cartridge. This little hat that I've built, it's just the cap of a motor screwed directly onto a VEX encoder. You don't even need the rubber band. And of course, a little shaft to go through here. Well, a big shaft, but a short, big shaft. And 2 wires. To use the software, come over down here to Github, where you can find a link in the description below under the video. Click on Code and copy the URL. Then in Visual Studio Code, you can clone a Git repository. It'll ask you where you want to put it. Select a folder and select Repository Destination. So now we're ready to download in Pros. We can say Terminal, New Terminal, Pros, Not. It'll automatically compile, download, and run the terminal. And from here, you can switch over to the brain. Once you have the program on the brain, you can plug into any 2 ports. It'll figure out automatically what port numbers they're on. So we connect 1 wire to the sensor, get the motor mounted on the gearbox. So we're going to plug the known good motor in and start the program. It's going to tell us what ports it found, and it's going to go right into running a test. Found motor 15, sensor 12. Once that's done, we can unplug the motor. We get a disconnected warning. We can ignore that. Motor reach speed of 228, greater than 200, pass. Motor track position matched, pass. That means that this encoder agreed with this encoder built into the motor. And the same in reverse, negative 227 RPM and track position matched. How about this motor? We don't know the state of this one. No need to restart the program. We can just plug it in. It'll jump right into a test. It's like this motor's dead. Nothing happened. So here's another one. Let's see what we get with this one. So it found it. It's not spinning. Forward performance, speed failed. Didn't move. Reverse performance, speed failed. We didn't move. The positions were equal because we didn't move. So this encoder agreed with this encoder, although they didn't move. And again, we can just unplug it, ignore the motor disconnect warning, go on to the next one. Plug it in. What do we find? It's squealing. Yeah, that's a bad motor. Cancel the warning, plug the new motor in. What are we going to get? Seems to be good, 213 RPM and 220 in reverse. Generally, you should get numbers around 210 to 230. So hopefully you can use this program to turn your motors that are bad into a smaller pile of motors that are good.